All right, so recording has started, and I'll share my screen. All right, so as we said, we'll continue with our review. Last lecture, we talked a little bit about the inheritance, and we say the idea of inheritance is to avoid redundancy in the code, and it's more general than creating separate classes. Let's see this example. Let me just let's consider this example. If I have the class A, class B, class C, and in every class you can see in A I have integer x, y, and z. All right, in class B I have integer x, y, and w, and in class C I have integer x, y, and v. All right, so there are something common between these classes. This is the main idea of of inheritance. Since I have a few things in common between classes, like here in this case, this x, y, z, all right, and in the applications that we talked about, for example, in student and employee, we have name, email, etc., and they have one or more than one, not necessarily to be more one, but let's assume that we have one different variable here. So the common thing can be put together in one class. All right, this is of course will be converted to be like this. So I'll take the things in common. All right, so my idea or my advice is whenever you have attributes or methods that are in common between classes, it's recommended, highly recommended, to put them in one class and inherit them in other classes. So I'll take x, y, I'll put them in class S, okay, which is called superclass or parent class or base class. In all cases is the same meaning. All right, and I'll put the common things, the common members. All right, now I have this class, which is S, which includes things in common. Now the rest of the classes, class A, and I put this column, which means inheritance will inherit everything from S. Okay, and I will add integer Z, the remaining here. The remaining is Z. So you now you know how to do this for class B. Also class B will inherit from S, and then I will add the integer W. Class C also will inherit S, and there will be the integer V. And that's it. This is the basic idea of inheritance, to put the things in common in one class and inherit these things in other classes. Now, the advantage here, if I want, for example, to change X to be X1, then in this case, I have to come and change X1 here, change it here, and change it here. While in the second case, it's enough to change it here, and the change will be reflected to all other classes. How inheritance works. So I have, for example, this class S, public integer X, integer Y, public. I don't need to write public again here. Void print, which will print the value of X, Y. Now, if I have, this is the superclass. Okay, if I define another class A, which inherits S, then I can add this, but I have access to everything here. For example, here, if I define a variable A1 of type A, then I can use A.Z, which is here, right? But also I can use A.X, which is in the superclass. A.Y, also it's in the superclass. And also I can use the print, which is also in the superclass. So Actually, the derived class or the subclass can use all the variables, all the functions available in the superclass. This is an example of the point. See, now I have in this very common example. You'll find it a lot in books and on the net. So here I define class point, which has X and Y and public point. Of course, this is the constructor, if you remember, and we'll talk about it again. Very important. We talked about it like last lecture. The constructor. It has to be the same name. All right, it has to be public and returns no value. So usually we use it for initialization. So in this case, I have this class, okay, and also I have these methods, which is get X, get Y, set X, and set Y. And if you remember, we called this as mutators. No, this accessors or getters, right? And these are the mutators or setters. All right, and I have also print, which prints the point. This class is very clear. Now I can, since I'm talking about inheritance, then if you consider the circle can be described in three things: X, Y, and R, right? So instead of creating a new class which includes X, Y, and R, I can get X, Y from the point. All right. So in this case, public, of course, circle inheritance or inherit point, public double radius, and circle of. Now this is the constructor, very important. Again and again, I repeated it several times. Here the constructor will include X, Y, and R, but X and Y do not belong to the circle. These are not the circle's own. Okay, they belong to what? To the point. Okay, so I'll pass them. I'll take them from here and pass them to the point, which is there. Okay, to initialize the point. Okay, so when you create a constructor for a subclass, then and pass the argument to the superclass, you have to pass them here like this. Dot or colon, and then you send the X and Y to the point, and the remaining is radius. All right. Of course, I have here another another function or method, which is find the area, which is pi r square. If you have more methods, you can use them. This is the code that you can use. All right. So this is used for inheritance. Now this is just clarification. This column is used for inheritance, just like this. Okay. The constructor. This is again a very important thing. The constructor of the subclass of the circle. All right. See, I have here point. Okay, and I have a circle inherits from point. Okay, then I pass here X, Y, and R, but actually X and Y, they do not belong to the circle, so the circle itself will forward them to the point. Okay, so this is what we did here in the constructor: integer X, integer Y, double R. R belongs to the circle, but X and Y will be forwarded to the point. Okay. Well, this is the main function. Okay, inheritance mode. This is also a very important thing because you need to identify the mode of inheritance. What's the mode? Differentiate between the types and the modes. Here we are talking about the 3 P's that we talked about: public, private, and protected. Okay, so the mode, when I write, for example, circle Then colon, here I have to specify what kind of, or what's the mode of inheritance. Point. The most commonly used is public. Okay. Public means the circle can access everything in the point except the private. Let's see. The derived class doesn't inherit access to private data members. This is very important all the time. However, it does inherit full parent objects which contain any private members which that class declares. All right. Also, in all cases, a private member in the base class cannot be directly accessed by the derived class. What's the meaning of that? It will have it. Okay, like here in the point, if you can see this point, I have private XY. Okay, this will be considered part of the circle, but I cannot here, I cannot use X or Y. Okay, I cannot change them because they are private. I cannot have direct access to them, but it will have them. So let's go back here. Now the mode of access, or the mode of inheritance mode, the inheritance modes are public. The public member of the base class will become public in the derived class. And the second one is the protected. It's better to show you this example. It will explain everything. Now I have in the class A, I have public, I have protected, and I have private. Now, if the inheritance is public, then the public will be public, the protected will be protected, and the private will be private. Okay, not possible to be accessed all the time. If I have protected, then the public will be changed to be protected, and the protected remains protected, and the private will remain private. If I put the inheritance or the mode is private, then everything will be private. So actually, see, the highest level of access is public. Then it comes the protected. Then the private. Public and inheritance, if it's protected, in public everything will be the same. And protected, then I don't have public. The public will be protected. And private, I don't have public, and I don't have protected. I have everything private. Okay, so it's possible to go down to limit the access, the visibility, but it's not possible to go up. This is not possible. I cannot change the private into protected, or the protected into public. So if it's public, then the class will, everything will be the same, protected. The public will be protected, and private, everything will be private. Now the inheritance type, if you remember this diagram that we created, actually here we have single inheritance. This is most commonly, or in most of our examples was about the single inheritance. Like I have basic class and I have derived the attributes and the methods. All right, so it will inherit everything, and of course it can add its own attributes and methods, more attributes and methods, but it will inherit everything here. So this is the way we write it: class, subclass, name, like as we did in circle. Access mode, if you don't write it, then it's private. If you write it public, for example, and then the base class, which is in our example was point. Then here you can write anything else. Okay. Let's see this before inheritance and after inheritance. Let's take the first example. This is before inheritance. I have class A. Okay, I have class A. I have public constructor, and the constructor Of course, it's most commonly to initialize the values, but here in the constructor, we will just print a message. This is class A \n, and that's it. All right, class B, public, again, B, the constructor. This is the constructor. This is class B. All right, then here, when I declare a variable here, when I write A, remember, this is very important, and it was one of the questions in the midterm exam. When does the constructor being executed? All right, or when the constructor is called. Here, actually, it's called when you declare a variable of that type of class. So here we call the constructor. So when you define a equal a small a as of type A, then it will go directly to call the constructor and execute the constructor. Okay. Now B also, it will go and call the constructor. So the execution of this one is, first of all, it will come to the main declaration of an instance of class A. It will print this. All right. And then when I declare this, there's no print here, right? No printing, but actually it will go to the constructor and print this message. Okay, now let's see with inheritance. I have class A, okay, public A, of course, this is class A, the same thing. Now I have class B, which is a subclass of the class A, and this is class B. All right, see now, focus with me on the definition of B. The first one is just to print declaration of instance. This is what we got it, what we did, and then declare A. This is class A, and declaration. See the B in B. Please focus with me. Now, when I declared B, okay, it went to B. All right. But it found that B inherits inherits A, then it will go again to A. Again, when I declared B, it will go to B. Before executing B, it went to A. Then the constructor of A says that print, this is class A, and this is what we got here. All right. Then after it finishes, it comes to the class B constructor and print this message. So actually, if the inheritance, or if I declare a variable of type B, then it will go to the superclass, then to the subclass. So this is an example of a single inheritance. I have class car, public car, this is the constructor. Nothing in it, just another message. This is a car class. And when I declare a variable here, define a new class truck, public car inherits from public car, and public truck, see out, this is a truck class, etc. Then when you define a car, all right, what will you get? When I define car, see, it will go there to the car and print, this is a car class, and that's it. When I declare truck here, it will go here, but before executing, it will jump there and it will write, this is a car class, then it comes to execute the constructor of the truck. Then this is what I'll get. This is a car class, and this is a truck derived from car class. So again, I have this car and I have truck. This is very important, please. So when you declare in the main function truck T, all right, it will go there. But before executing the constructor, it will jump to the superclass and execute that constructor. Here in this case, it prints this is a car, and then it comes back to the track and execute the constructor. So remember, 1, execute superclass constructor, then 2, execute subclass constructor. Is it clear? Multiple inheritance. Of course, here, if the it's supposed to be like this, I'm sorry. Okay. So that means I'm inherits, or the derived class inherits from multiple classes, and it will take the attribute 1, the method 1, attribute 2, and methods 2. All of them will be inherited here. How to use it? You can use it here. Subclass name, let's say, for example, yeah, car, or bus. All right. Access mode, you can use it public. Okay. From cars, and another access mode, comma here, public from vehicles. If I have these classes. All right. If you have more, you can continue and have more. So in this case, if you can see this multiple classes. Class A1, public A1 constructor. This is a class A1. Class A2, also the constructor. This class A2. Now, if you can see, class B inherits from A1 and from A2. So when you declare a variable here, it will go to class B, but it finds that it inherits from A1 and A2. So it will go first to A1, execute the constructor here. Okay, so I'll get, this is the first message. This is class A1. After it finishes, it comes back and finds that still I have A2. Then it goes to A2 and execute the constructor. This is class A2. After it finishes, it comes to the base class and prints this is class B. All right, and that's why we got 3 messages or 3 printed messages here. Okay. Multiple inheritance example. See, for example, here it's just an example: car, vehicle, and truck. Now, if I declare truck here, okay, the truck will go where? First to truck, and it finds that it inherits from car. Then it will jump to the car. It will print this is a car class. After it finishes, it comes here and finds there's another inheritance vehicle. Then it goes to vehicle and prints this is a vehicle class. After it finishes, it comes to back to the base class. So this is the message that you got. This is a car, this is a vehicle, and this is a truck class. All right. Multi-level, that was multiple. Differentiate between multiple, which comes from several classes, and multi-level. In multi-level, you have superclass, okay, class 1, and you have subclass of class 1, class 2. This is subclass. But at the same time, it's a superclass of derived. Okay, that means I have multi-level. This is the first level, and this is the second level. So, for example, here, class A, public A, see out this is A1, A2. If you can see here, A2 inherits from A1, and B inherits from A2. So when it comes here, when I declare B, it will go to A. Right here from B, it will come to B, then from it will go to A2 and finds that it inherits from A1, then it executed A1 first, then A2, then be there. All right. Okay. Hierarchical and inheritance. It means some way or another it's similar to a pyramid or hierarchy. That means every class can inherit from the class above. Also, this example is not. You can check it. I just want to to explain everything. So hybrid inheritance. Hybrid means the inheritance is variable and it can inherit from different classes without any regularity. All right. So this is all about inheritance. And still we have 10 minutes before the quiz. Okay, the abstract class, it's very important also, the abstract class and the polymorphism. The abstract class, actually, this the next question in next lecture, or it's short quiz, will be about abstract class and polymorphism. Okay, so abstraction is displayed only essential information and hiding the details. So we said, what's the advantage of having abstract? The user does not need to access everything and to know about all the details. So in general, it's better to make it like an interface. All right, like using your mobile. All right, you don't care about the software, how it works, what's happening inside. You just want an interface that you can use. So in this case, this is the pure virtual function. Now, if you define this pure, this is the first way. Of course, we'll talk about them in the next slide. The first way to abstract is to define a superclass and define a virtual function regardless of the type and regardless of the name, but it has to be equal to 0. This is very important to make it pure. Okay, virtual function. Okay, so set W is all right, set H is all right, protected W, and it will inherit everything. So it can, any object that can use or inherits from shape can use everything, except that any object, any new class inherits from shape should define this function. This function should be defined, all right, in that class. It's not defined here, not like there here. Set W, W and W equal W. All right, it is defined here, but this one was not defined. That's why the subclass should define it. Let's see here. A class rectangle public shape. You can, without this virtual, you can use everything here. But since I defined their virtual and equal 0, then you should declare the same function here, double get area, return W times H. That's the same name, the same type, all right, but with different functionality. Now triangle, also it inherits from shape, public, double get area, return W times H over 2. If we're talking about square, also double get area. So what if you don't define this? If you don't define this, you will get error. All right, I think I showed you this error. No, if you I think practically I showed you this. If you don't have, or if you don't define this function, then you will get an error. Okay. This is the full program, and you can copy it and paste it. All right. Now polymorphism. I'll stop here to give you opportunity to ask before the quiz. and we'll continue. We'll talk about the review the polymorphism in the next lecture. So please, if you have any question, you are free to ask. I'll stop recording also to give you the quiz. We don't need to keep the recording for the quiz. All right.